Hello everybody, welcome back. This will be the only section that we're doing this week because this week we're not having a quiz this Friday. Rather, we're going to have our first exam on Friday. We'll facilitate it the same way we have been doing the quizzes. This could change after this first exam. We'll talk about that. But the material in the exam is through section 3.2. All of your quizzes through section 3.2, which we haven't discussed yet because that's what we're doing today. So today's material will be on the exam. The exam runs through section 3.2, and it'll be administered again on Thursday. So what is section 3.2? Well, it's called quadratic functions. You should be quite familiar with this. We're going to talk, for example, the quadratic formula. I know everybody's aware of the quadratic formula. So definitions, and then forms of equations, standard form and general form of an equation of a line. And then for the most part, what you're going to be doing is solving them. So what you were doing in Algebra 2 when you were factoring, and the quadratic formula for that matter, you even might have completed the square, which we do have to, this is part of this class. But so that's what this week is about. Here's the assignment. It's again due on Friday, but because of the test, I'll take that all weekend. A lot of people have been writing to me and said, "Oh, I'm so sorry about the late homework assignment." Homework assignments I'm not grading, just checking boxes, just so you know. Okay, let's get to mathematics. Quadratic function definition. A quadratic function is something that has a square in it. A polynomial with degree 2. It has a square in it, and it is represented by a parabola. Representative. Parabola. And so that's how I would define it. And then, so here is one, something looks like that. All of these have what's called a vertex. And that'll either be the max or the minimum point. That'll also define the domain. The domain for this one is from that vertex all the way up to infinity. It also has what's called an axis of symmetry going through that point. It's called an axis of symmetry. Axis of symmetry. And what an axis is, parabolas are all symmetric. That's the whole thing. It's squared. It's second degree. It's an even function. And so you can fold it in half. Every point here has a corresponding point over there on the other side of the axis of symmetry. If you go from that far from the axis of symmetry, the parabola on one side, you're going to go that far to the other side. So that's what they are, and that's what it's all about. And so let's work with them. First off, I guess the forms of lines. There's two forms. One is called general, the other is called standard. Well, the general form looks like this. A, B, and C are real numbers. A, B, and C are real numbers, and that's where the definition comes from. It's represented by a second-degree polynomial. If A is greater than 0, then it has a min. It opens up. Let's put it that way. And on the other hand, opens down. And we'll even go so far as to say it opens up, meaning there's a minimum point, meaning there's a maximum point. And I'll probably get back to that a little bit as we go. So there's what's called the general form of a quadratic function where A, B, and C are real numbers. They should be integers. There's also a graphing form, a standard form. And this is what you would do to graph, what I would do to graph form. F of x, A, x minus h plus k. That's squared. It's plus h. Yeah. A times x minus h plus k squared plus k, and then the reason that's the standard form is because that kicks out the vertex. Vertex is hk in the standard form. And actually, let's go back to the general form and really talk about this, this thing, vertex. If you have it in the standard form, the vertex just kicks out, and we'll do an example of that. But if it's in the general form, x squared plus bx. If it's in the general form, then the vertex is at the point where x is equal to the opposite of b over 2a. And then the function's value, that's the x value of the vertex, then the function's value would, you need the function at, let's do it like this. The point then, the vertex, opposite of b over 2a, f at opposite of b over 2a. And there's the, that would be the vertex of the function. And so I guess we'll just kick out an example. We're down to 2x squared minus 6x plus 7. For example, find the vertex. Determine the vertex. Vertex is at the point opposite of b over 2a. That's what x is. And so x is opposite of b over 2 times a, 6/4 or 3/2. And then, so that's the x value of the vertex. The y value of the vertex, then you put the 3/2 in the function. The function's value of 3/2 is 2 times 3/2 squared minus 6 plus 7, and I did that already. Is 5/2. So the vertex is at the point 3/2, 5/2. That's the vertex. Is that positive? Yeah, I think it's positive. Yeah, that's positive. Okay, so that's good. And then, so in general, the standard form then would look like this. F of x equals a 2. That's not going to change. And we'll talk about that number. Times x minus 3/2 squared plus 5/2. Right there's the vertex. Okay, general forms of equations of lines. Ultimately, you want to solve these. That's where we're headed. Max, min, domain for any polynomial function, in particular quadratic functions, is all the reals. The range is either from negative infinity to f at negative b over 2a, or it's from f at negative b over 2a to positive infinity. One or the other. That's the range of them. One or the other. This would be a max. And this occurs when the leading coefficient, a, is less than 0. This would be a min. And a is greater than 0. The domain, the domain for this function is all real. So the range for this function is, let's see, that it opens up. It's everything, the range is everything from 5/2 up. Range for this function. 5/2 infinity. Because it opens up. This point is a min, because that's positive. Okay, max, min, domain range, we're over here, x, y intercepts. The intercepts, the y-intercept is too simple. Sorry about that. Intercept. You'll let x be 0. And then whatever it is. The y-intercept is 7. You just let x be 0, and it just kicks it out. Here, you'd let x be 0. You'd actually have to, you'd get 7. You let x be 0. If it's a general form, it just kicks right out. The x-intercepts, that's what we're doing. We're solving these things for the x-intercepts. That's the whole point of all the Algebra 2 work that you've done. You want to solve these to determine x-intercepts. What that means is to solve. There's 3 ways to solve. 1, factoring. If you're good at factoring, I am, factoring just cuts off a lot of time. if you're good at factoring. That's why you did that so much in Algebra 2. 2 is called complete the square. We will have to deal with this sometime this semester, but not now. But you can complete the square, and as a matter of fact, we do that before the quadratic formula, because if I was developing the quadratic formula, I would have to complete the square. And so the quadratic formula, your factor quadratic formula is x opposite of b plus or minus square root b squared minus 4ac all over 2a. Whoops. A couple examples, sure. Couple examples. Well, let's just do one example. 2x squared plus 4x minus 4. F of x equals 2x squared minus 4x minus 4. I think. I forget. Both minuses. Plus 4x minus 4. Okay. There's an example. I would try to factor that. First off, you can factor 2x, and this would actually be called x squared plus 2x minus 2. But you can't factor that. I mean, you can factor the 2x, that's what I just did, but you can't factor that, so you have to use the quadratic formula. Opposite of b, plus or minus square root b squared, minus 4 times a times c. 4 times a, 2 times c is negative 4. All over 2a, 4. There's a bunch of 4s in here. Minus 4 plus or minus square root 16 plus 32. There it is. But, let's simplify this. I guess I'll go down here. Negative 4 plus or minus 16 times 3. 4 times the square root of 3 over 4. One more step and we'll stop. I'm going to make an example video with a whole bunch of these in. Negative 1 plus or minus the square root of 3. Those are the two solutions. One is negative 1 plus the square root of 3, which is about 1.7, so that's 0.7. Negative 1 minus the square root of 3 is about negative 2.7. Okay, thanks. I'll be right back.